Welcome viewers, I am Venkatesan. Today my lecture is about mathematical induction. In last lecture we started mathematical induction and we discussed two problems. Today we continue the third problem. The question is, using mathematical induction, show that summation r is equal to 0 to n, 3 power r is equal to 3 power n plus 1 minus 1 divided by 2. My left hand side is summation 3 power r. I want to prove 3 power n plus 1 minus 1 divided by 2 using mathematical induction. Let me consider the proposition as P of n. Here P of n is 3 power 0 plus 3 power 1 plus 3 power 2 etc. up to 3 power n. I am simply expanding the left hand side, that is equal to 3 power n plus 1 minus 1 divided by 2. This is my given proposition. As usual, we are going to consider the initial step as basis step. Remember, here summation r is equal to 0 to n, which means that my initial value is 0 for this problem. So in basis step, I want to verify P of 0 is true. So in basis step, to prove P of 0 is true. So my initial term on the left hand side is 3 power 0. That is equal to right hand side replacing n value with 0. So 3 power 0 plus 1 minus 1 divided by 2. Here in both left hand side and right hand side, the answer is 1. That is 1 is equal to 1. Hence P of 0 is true. My basis step is proved. Second, in inductive step, I am going to assume P of k is true for any positive integer k. That is, my left hand side is 3 power 0 plus 3 power 1 plus etc. plus 3 power k is equal to 3 power k plus 1 minus 1 divided by 2. This is my assumption now. I want to prove P of k plus 1 is true. That is, right and left hand side expand up to 3 power k plus 1. On right hand side replacing k value with k plus 1, which gives you 3 power k plus 2 minus 1 divided by 2. Consider the left hand side for proof now. My left hand side is 3 power 0 plus 3 power 1 plus 3 power 2 plus etc. plus 3 power k plus 3 power k plus 1. By using inductive hypothesis, we can replace first k terms as 3 power k plus 1 minus 1 divided by 2 plus my last term is 3 power k plus 1. After taking LCM, I get 3 power k plus 1 minus 1 plus 2 times of 3 power k plus 1 divided by 2. Here I am just taking 3 power k plus 1 common from first and last term. If I take 3 power k plus 1 common, on first term I will be having 1. On the last term I will be having 2. So 1 plus 2 becomes 3 here. So 3 times of 3 power k plus 1 minus 1 whole divided by 2. Here 3 power is 1. Here 3 power of k plus 1. While adding both the powers, I will be getting 3 power k plus 2 minus 1 divided by 2. This is my required right hand side. Therefore, P of k plus 1 is also true. Hence, by principle of mathematical induction, P of n is true for all positive integers n. Problem number 4 now. Using mathematical induction, show that 1 by root 1 plus 1 by root 2 plus 1 by root 3 plus etc. plus 1 by root 10 greater than root 10 where n greater than or equal to 2. Remember, here my initial value is given as 2. N starts from 2 here. Solution. Let the proposition be. As usual, you consider the proposition as P of n. In basis step, we want to verify P of 2 is true because my initial term is 2 in this problem. So to verify P of 2 is true, consider first two terms on the left hand side, that is 1 by root 1 plus 1 by root 2, which is greater than, on right hand side replacing n value with 2, that is root 2. Of course, 1 by root 1 plus 1 by root 2 is 1.707, which is greater than root 2 value, that is 1.414. This is trivial answer only. Hence, P of 2 is true. Next, in my inductive step, I want to assume that P of k is true for all values of k. That is 1 by root 1 plus 1 by root 2 plus 1 by root 3 plus etc. plus 1 by root k, which is greater than root k. I want to prove p of k plus 1 is true. That is, on left hand side replacing k value with k plus 1, or else extending up to k plus 1, and on right hand side replacing k value with k plus 1, I got greater than root of k plus 1, which is true. I want to prove. Now consider the left hand side alone. My left hand side is 1 by root 1 plus 1 by root 2 plus 1 by root 3 plus etc. up to plus 1 by root k plus 1 by root k plus 1. As per inductive hypothesis, I can replace this first k terms as root k. But in inductive hypothesis, how do I consider? My left hand side is greater than right hand side. So when you are replacing it with the root k, my inequality varies here. This equal to changed as greater than symbol here. So greater than root k plus the last term is 1 by root of k plus 1. While taking LCM, root k into root k plus 1 plus this numerator 1 divided by root of k plus 1. We know that root a into root b is nothing but root of ab. Likewise, here it is root k into root k plus 1 becomes root of k into k plus 1 plus 1 divided by root of k plus 1. I know that k plus 1 is greater than k, so this is greater than. I am replacing this k plus 1 value with the k. We know that square root of k square becomes k on the next step. Hence, my numerator is k plus 1, and I don't make any changes in the denominator. I maintain the denominator as root of k plus 1. While cancelling it out, you will be getting root of k plus 1. That is my required right hand side. Therefore, p of k plus 1 is true. Hence, by principle of mathematical induction, p of n is true for all positive integers n greater than or equal to 2. Thank you.